All right, the other approach that we're going to talk about that's specialized for finding the roots of polynomials is Bairstow's method. And with the context of polynomial deflation, then we can understand Bairstow's method. So let's recall polynomial deflation here. It's right. So let's say x plus 1, x minus 2, x plus 3, x minus 4, and maybe we'll do x minus 5. How about that? All right. So we have this, and then we could divide it out. I like another color for that. Okay, and we can divide that out by one of the roots. Okay. So but we don't know what the roots are, right? So let's say we divide that out by x plus something here. All right, and we're going to use t. That's the notation, just doing a notation check. And actually, instead of saying plus, because that's actually the guess we're going to use. That's not a very good eraser. That's a better eraser. Okay. And then we're going to use x minus t so we can say that t is our guess. So if we just guess something instead of actually knowing the root, then we have this t. Then we could actually represent then. After we do this division, so we can do this division, and we're going to get a polynomial of a lower power, and so if this part of it, if the numerator, if that were f of x, so this is fifth order. Okay, so let's call that f5 of x because it's a fifth order polynomial. If we do this division, then the result of that is going to be f4 of x, and that's going to equal whatever, right? It's going to equal something, and what the notation that we're gonna use here is we're gonna say, all right, so that's something actually. So, but the whole point is it's fourth order plus remainder. Okay, and the whole idea behind Bairstow's method is to just keep guessing, and you have to modify your guess systematically. So if we have some intelligent method of modifying our guess until we get closer and closer, so that we reduce this remainder, because as this remainder goes to 0, then we're honing in on one of the roots. And so what it actually uses is we guess a root here, and we actually guess 2 of them at the same time, because anyway, we guess 2 at the same time. But then the method that we use for minimizing this remainder is actually the Newton-Raphson method. So we use the Newton-Raphson method for minimizing the remainder. I'm just going to write that here. Uses Newton-Raphson to modify such that remainder is I would say goes to 0. All right, so that's it. That's Bairstow's method.